BSc Part 3rd Nuclear Physics. Today we are discussing what are nuclear forces. For this, we know that a nucleus is made up of nucleons, which means proton or neutrons. Since proton is a positively charged particle, so there will be repulsive Coulomb attractive force between these protons, even in the case in which they stay very near to each other in the nucleus. It indicates that there must be another force which binds these nucleons strongly. This another attractive force is called nuclear force, which binds all nucleons in the nucleus and remain effective only within the range of nucleus. So if we compare this nuclear force with the gravitational and electromagnetic forces, then we find that the nature of this nuclear force is very complex. Here are some properties of nuclear forces. We discuss them one by one. First property is attractive force. This is attractive force. Nuclear force is an attractive force, and it is the strongest force among other fundamental forces in the nature. If I assume the strength of this nuclear force 1, then the strength of EM force, electromagnetic force, would be 1 by 100. Similarly, the strength of weak force would be of the order of 10 to the power minus 5 to 10 to the power minus 14. Similarly, the strength of gravitational force would be of the order of 10 to the power minus 39. Because the strength of gravitational force is lowest, so the weakest force of the nature is gravitational force. Second property is short range. So nuclear force is short range force which remain effective in the nuclear radius, which is of the order of 1.5 Fermi to 2 Fermi. Third property is spin dependence. Nuclear force depends upon the spin of the nucleons, protons or neutrons, which are interacting with each other in the nucleus. Next property is charge independence. This property indicates that the nuclear forces does not depend on the charge of the nucleons, which means nuclear force between proton-proton, neutron-neutron or proton-neutron are same. Means whatever be the charge of the nucleon, the nuclear force will remain same. Next property is charge symmetry. The strength of nuclear force which are interacting between neutron-neutron and proton-proton, then the strength of nuclear force interacting between neutron-neutron, proton-protons are similar, but the strength may be different in the case of neutron-proton. So it is also observed that the nuclear forces depend upon the total isospin of the nuclear states. Isospin for neutron and protons are half. Saturation property 6 as saturation property. Nuclear force acts only between the two nearest nucleons, and it is negligible for other nucleons, which means the effective nuclear force is between the nearest situated nucleons, and this nuclear force is negligible for other nucleons which are situated far away. Next property is exchange behavior. Nuclear forces are one of exchange forces. Heisenberg observed that this property can be used to explain the saturation property of the nuclear forces. Non-central components and tensor forces. Some part of nuclear force has non-central component, which is also called tensor force. Apart from this tensor force, the coupling between spin and orbital motion of a nucleus also produces non-central forces. This tensor force is independent on the velocity of the nucleons, while the non-central component, which arises due to spin-orbit coupling, depends upon the velocity of the nucleons. So these are the basic properties of nuclear forces.